everybody. Good morning to the participants that are here in person and all participants that are online. This is the second day of our joint workshop with the National Science Library of the Chinese Academy of Science and the SciELO. The idea is to advance a collaboration on open science research communication infrastructure. So yesterday we had the first day, which was very, very productive, very informative. We started to discuss lines of cooperation, which was very productive in the sense that we have much to do together, but we need, of course, to align our visions, converge our visions in our capacity. So today we will continue with the second session of the workshop. We are going to focus on the technological framework and the artificial intelligence applications within the portal, within the system PubScholar that we saw yesterday. So the first we have now the participation of Professor Shinichi, who is the director of the Knowledge Technology Department of the National Science Library. He will share with us a presentation on the technological infrastructure and the artificial intelligence capabilities of the PubScholar.
Okay. Today we will give more details about PubScholar technological infrastructure, and I will just show some AI ability works in China. So we at least begin and tell how we use AI to enhance our system. So the first, we will give an overview of our platform about the PubScholar architecture, and in this figure we have build how to build the PubScholar infrastructure and develop AI capabilities. And we know it's very difficult to gather all the data to store our PubScholar database. So we want to give the unique standard about our PubScholar data standard, and this is very important for after the first job. And we have facing some difficulties to do, because we have the data right, and we can't afford some difficulties, and we give a very high price. And after we have some resources from all the internet, but not the resources are high quality, and some of the resources are not really high quality recognized. So we must figure all this hard work, and we can make all this data reusable and high quality and more smoothly to our users. So there are 5 different difficult work we have facing. So PubScholar want to looks like the same like a service. We can see PubScholar make blog literature resource retrieval system. That's with look like from the face. It's not just a very easy architecture. We can see we have already gather all different kind of resources from all over the world, like journal, like our research data, like the patent, like others open softwares. We gather together, we uniquely together and do this one stop, one website can users can retrieve at one time. This is our PubScholar platform architecture. From this figure, we can see all the whole of the architecture. We can start from this level, the bottom. This is the technical data foundation what we should build, and we have a storage that is built on our library. We call it the infrastructure cloud. This supports us to store all the metadata, all the full text from all over the world, from all different resources. And we, after we have access our data source to our database, so the next step is we have to do the data processing and make the necessary index in our system. This is the first two steps, and then we extract the knowledge from the articles, like the method, like problem, like others. That is the necessary aggregate we must extract from our literature. And then we build the knowledge graph and make the semantic retrieval engine. And therefore, we can do some knowledge retrieval function. So the search we copy with either AI, like language mode. We can embedding AI in our system and give us the AI computer power support. And the third, and this we all have to security and privacy protections, because a lot of people have registration and the scholar have registration to our platform. They can upload their paper, their manuscript to our system. We make sure that the data should be stored in our storage security and provide the privacy. So we also open some necessary technology APIs to our system to do the intercooperation work. So this is not the data foundation. That is the bottom of the PubScholar. And above this layer is the resource layer. The resource layer, we can divide to the resource to different type of the data resources, like the open access journals, like the patent from all global patent, and we call it the scientific data, but it's research data. The user writing manuscript and they can upload to our system to the journal. This is called scientific data, and then we collect large for research facilities that can provide open service to our global users. And then the software, open software is very important. Like in part, like others, we can have the contract with them and then collect the data, and they have give us the API and harvest the data from their platform, and we can store the metadata and make the indexing and provide the services. We also collect the online ebook in our database. So that is all the different 6 different types of resources in PubScholar. In the right of the resource layer, we also have some resource integrations and make the difference, because all these resources we have a collection from our partners original set of resources. We have to do some data precise, because we can make some extraction like the picture, like a formula, and other things. We extract the necessary entity data from our paper, from our literature resources, and we organize all the data so that can provide the more value from our resource layer. So the resource layer is divided to two parts. One is origin, and one is process the data. So above this one, that is called the core platform services. We have some different functions here. You can see four many functions in our core platform services. The first one, we call it resource discovery system. Now we call it a knowledge discovery system. We have the unique one-stop search function, and we also have metadata indexing. We use VS and other open source software to support this. And we also provide the physics and navigation, and we have the cross-resource discovery, because one paper comes from different way and from different platform. We can discover the full text from our system. Then we have personalized recommendation. This day afternoon, I have already introduced about our Keshun headlines. That is this function. So the second is full text access and multi-channel navigation. So we do have some full text that already have it understood in our PubScholar database in local, but not all this full text is stored in our own database or not centralized anything. So we have to make the different link to the original database or platform or website. So we navigate the user not only can download the full text from our own platform, it can also redirect to our partner website and download the full text and provide some other services. So we call it the link navigation. That is this function. The third, we can provide the open access first. So not all the paper is open in different platform, especially in China. Sometimes the journal, its own website, can open this paper firstly. We can give the user the first open access link above. Yes. We also provide the users the write and the lessons wheres and the full text viewing and downloading, and so on. These functions. The third function is intelligence service. We call it. You want to know more about our AI provider services. Maybe our colleague in the third will be Dr. Bai Yue will give more detail about our AI functions and the AI architectures. So this is the services we have integrated to our PubScholar platform. They have semantic knowledge, regression, data rich deep reading, and intelligence enhanced retrieval system, and we have AI chat, and we have intelligence literature review, and so on. We provide various functions that already integrated in PubScholar platform. The third one, this function provides the money to for communication. We have the preprint, China archive preprint, and we can provide open peer review, and we can support the reviewer. Our system can give their suggestions or something. We also provide journal and publishing services. We have a research network. We can connect with each other and work with each other and sharing our data source and the reviewers. And we also provide the researcher their own personal profile. We can see their login and see their introduction and see all the papers they have already published on their manuscript here. So on the top of the layer, we have governance framework, and this is the policies and compliance, and about the partnership and cooperation. We have substantial trust, and we also for the OS10, Jinsha have already introduced about the open science platform, and then this is the top layer. We can cooperate and integrate with others platform. So this is the whole core architecture about PubScholar. And the second, we want to introduce some details about our AI capabilities of PubScholar. This is our history about AI. Because before 2023, there is no national, but after the 2023, all over the world have like in the OA. But after ChatGPT in October of 2023, we have already launched our own scientific literature language mode that we cooperate with our partner company. Its name is called Type. They very they do a lot of good work in translation and make the literature to the software, the voice. They very in this field they do a lot of good job. So we cooperated with our partner Type, and we made this scientific literature language mode. And now we have the version with 2.0. We want to make AI-driven innovation in our application in the literature services. In the first, we provide the three main functions. That is result integrations and paper deliberation and study, and we also do some paper academic writing here and support for our researchers. So under this work, we have grade of computers computing power support our the platform. We have more than 10,000 views that is located in Atlantic, in Clovis City. Yeah. Then this is four different functions that are already embedded in PubScholar. The first, we can make the AI enhanced retrieval. After we tell PubScholar what we want to study, PubScholar will using AI ability and understanding what you say and understand what you want. and analyzes your requirements and make the retrieval from our index and give the right limited answer to for our need. On the right, there we have a assistant, and you can make the dialogue with our AI robot. So after that, we all have AI power integrating literature reading, because when I open one of the literature articles, we have the full text downloaded here. If one person will cost hours to understanding the paper meaning, but with the AI support, the AI can give us a short brief introduction about the creation, the most most qualified of the paper, and they can translate a different language for you, so we can understand this paper quickly in less than 5 minutes. So that's very quickly for the researchers understanding each paper. After that, we will make all the review of our field. The AI can give the support for the literature reviewer of if the paper you have read, you have download, you can give a short report about that. So this is the 4 main functions we have embedding in our platform. So we can change like language mode here. We have 4 language mode already embedding our platform. The first one, it's called Chinese Hanshu. That is made by Chinese kind of size ourselves. That is English name. We have English name called Size 1. Yes, we use it firstly because it's our own. The second is on this is a alpha type. We call it the production rate. So next, Dr. Yue will introduce his from alpha type company. He will introduce more about the details. They are doing their work. We also have the open source language mode already located in our own database. So that is called Chainlink, that is from Alibaba company, and the DeepSeek, that is the open source from all the world. So we use this 4 language mode embedding in our system. And this is more details about our function. The first is AI enhanced retrieval. You can see from the website, we can make the retrieval. On the right side, the AI assistant can talk with you and make a short brief introduction about all the research results. And you can help and chat with the AI assistant, and they can help you to find the curated search results. And this is we can have the 3 different type of resources here. All the resources can embedding AI support. And this is the AI that is independent. You can check with it and so on. And this is the AI support literature reviewing, and they can give a short review report. You have visit, download all the full text or PDFs. This is the AI powered in intensive literary reading. This is the one of the paper. You want to understand the operation or the meaning of the paper firstly. You can give very short. You can read 1 or 2 paragraphs. That is a valuable paragraph you should read. And this is AI supported translation. We have already different 6 language translation with each other. That's including Chinese, English, and Spanish, and so on. And then that is the UNESCO international language have support this 6 language. We also want to explore the more useful for our service and partners. So we build the open AI agent community in our system. We call it XSIC. The XSIC using all our like language mode below, and we want to build a open agent community where like all the users can make their own workflows and choose which language mode you should use, and you can upload your own data to our platform. If you make a very excellent AI agent, you can upload and share with your partners all over the world. The users can reuse your AI agent here. So we have the 4 classes of the UI agents. One is for the literature, right? The reviewing type selection, knowledge system. And this is for publishing. We can use the AI agent for literature typing and manuscript publishing and so on. And we also use AI agents, service agent, and do the analysis, like the policy analyzing report and the emergency technologies report. And we also support some agents for AI for science and do some necessary work for help the scientists to do their experiments. And this is website of our agent. We have a series agent here. We call it agent matrix here. We have already have more than 20 useful and helpful agents here. So the users can register and use this online. That is people want to know how we can help the general editor and to review this paper with the AI support. So we build this academic reviewer agents that can help review the paper by AI. We give this action peer review, and we gave each paper which have a manuscript a score. We can see whether this paper is high quality or low quality. That can reduce the work for the journal editor. So the journal can embedding in this AI agent in their publishing system. It can execute all in the workflows. And this is AI assistant publishing service result of this. We can visit the Chinese website. So it translates some of it. We can do some review and recommendation. This paper is should be submit to which journal is fit for this article, this manuscript, and we can recommend some reviewers, which people can do the best work to review this paper, and we can give some suggestion and what is the high quality, why is the high quality and why is the low quality of this paper. Also can support some AI for science. Like for example, we can make the AI agent and help us to do the experimental analysis and do some scientific research reviewer and can help the scientists in our library. So the last one, the cooperation, we have already talked about it last afternoon, this afternoon. So thank you for your attention.
So now we have the presentation from Professor One, which is connected. Okay. Please, Professor, it's a pleasure to have you with us. She will talk to us about the OS10 Initiative and the open knowledge and the data sharing and the application standards. She is from the Open Science Research Center of the National Science Library. Welcome. Thank you.
Okay. Thank you. Can you hear me?
Yes.
Thank you. Good morning, everyone. It's a great pleasure to be here today at this workshop. I want to introduce the OS10 action recommendations and the open knowledge and data sharing specification framework. These documents are planned to be proposed at the UNESCO Global Conference on the International Decade of Sciences for Sustainable Development in Paris this July, especially in the context of the open science theme. The next slide, please. Today, I will focus on one main question: how OS10 can build on existing open science practices and support more connected, trusted, and practical cooperation among international platforms. Next slide, please. Thank you. Open science is moving from policy statements to practical action. Today, open resources are no longer limited to publications. They include research data, software, models, facilities, services, policies, and many other forms of knowledge. This creates new opportunities, but also new challenges. Resources are distributed across different platforms, described with different metadata practices and governed under different rules. AI adds another layer of agency. In AI era, resources need to be understandable not only to people but also to machines. They need clear identifiers, structured metadata, rights information, provenance, and relationship with other resources. The key issue is how to make open resource more connected, reusable, trusted, and useful across platforms and borders. This is the context for OS10. Next slide, please. Let me first start with the values behind OS10. First, because they explain why resource sharing, interoperabilities, and trusted cooperation matter. Next slide, please. Thank you. OS10 is guided by the fundamental values of open science: openness, inclusiveness, equity, responsibility, and sustainability, and trust. For OS10, these values are a starting point for practical work, broader participation, and better visibility of open resources, responsible reuse, long-term services, and transparent governance. Next slide, please. Open science principles are widely shared. The challenges is to turn them into mechanisms that platforms and communities can actually use. Openness requires a resource sharing mechanism. Equity requires better visibility and recognition, especially for resources from underrepresented regions. Responsibilities requires clear expression of rights, access conditions, ethical requirements, and data sovereignty. Trust depends on provenance, transparency, and governance records. Sustainability needs monitoring, feedback, and continuous improvements. The OS10 action recommendations provide the cooperation agenda, while the specification framework provides support for the implementations. Next slide, please. OS10 responds to this needs with two connected components, an action agenda and a specification framework. Next slide, please. Thank you. The action recommendations focus on 5 directions: sharing and interconnecting open resources, co-developing norms and standards, recognition open contributions, building capacity and equitable participation, and supporting continuous monitoring and improvements. The purpose is to move from general agreement on open science to practical cooperation among platforms, institutions, and communities. Next slide, please. These directions are closely aligned with the UNESCO recommendation on open science. Resources sharing supports open science knowledge. Platform and services cooperation supports open science infrastructure. Contribution, recognition, and capacity building support equitable participation. Multilingual description and semantic mapping help support dialogue among knowledge systems. Monitoring and evaluation support long-term improvements. In this way, the action recommendations helps translate open science principles into cooperation actions. Next slide, please. Thank you. The specification framework provides the rule base behind these actions. At the top level, it defines general principles, sharing architecture, exchanging mechanism, governance orientation, services, rights, and compliance. The metadata series then provides a common description layer. Part 1 defines general metadata requirements. The following parts extend this general layer for scientific literature, data, open source software and models, and large research facilities. Its purpose is to support discovery, exchange, association, reuse, governance, monitoring, and services across different types of open science resources. Next slide, please. For major platforms, the key question is how this framework related to existing standards and workflows. Next slide, please. Platforms such as SciELO already have strong practices. OAI-PMH supports metadata harvesting. JETS supports article structure, publishing, exchange, and archival workflows. Datasets, duplicate grassroots ORCID and the local metadata practices also play important roles. OS10 starts from these existing practices. Its added value appears when cooperation goes beyond one platform, one protocol, or one resource type. For example, a journal article may lead it to connect with datasets, software projects, funders, institutions, policies, and research infrastructure services. Open science monitorings may also require information about access, reuse, contribution, provenance, and impacts. So OS10 can be understood as a mapping-oriented cooperation layer. It helps existing metadata practices connect with broader open science use cases. Next slide, please. The framework adds value in four main areas. First, it supports cross-domain connection among literature, data, software, models, facilities, and services. Second, it provides a common mapping and exchange layer for different metadata practices. Third, it strengthens a governance-aware description, including rights, access, provenance, metrics, and record information. Fourth, it supports AI-ready processing because AI systems lead structured metadata, clear relationships, and merging readable rights and provenance information. Existing practices remain the foundation. JET continues to support publishing exchange. OAI PMH continues to support metadata harvesting. Local workflows and community practices remain important. Next slide, please. A practical way to understand OS10 is to see it as a shared layer about major platform practices. At the base are the standards and systems that platforms already use: JET, OEM, PMH, cross-ref dataset, ORCID, local metadata, and established workflows. The OS cooperation layer brings together common elements such as identifiers, agents, rights, access, relationships, provenance, metrics, and record information. On top of that, platforms can support new open science applications, cross-platform discovery, literature data software association, AI use, governance, monitoring, and shared services. The practical work can begin with metadata samples, mapping crosswalks, and voluntary patterns. Next slide, please. The AI area creates new expectations for open science resources. They need to be readable, reusable, traceable, rights aware, and connected. So next slide, please. AI for science and research agents depends on structured, reliable, and interoperable knowledge resources. For AI systems to use resources responsible. Resources lead clear identifiers, machine-readable metadata, rights and access information, provenance, links to related resources. The OS10 metadata framework supports these capabilities through common elements for identification, agents, rights, access, relations, provenance, metrics, and record information. The goal is to make open science resources usable as connected, traceable, and governable resources in AI-enabled research environments. Thank you. Next slide, please. International cooperation also depends on trust. When resources are shared across borders, platforms and users need to know who provides the resource, what rights apply, how it can be accessed, and whether there are restrictions or ethical and policy considerations. The OS10 framework supports this through rights and licensing expression, access conditions, provenance records, policy relationships, and governance nodes. This helps make openness more responsible and traceable across different jurisdictions. Next slide, please. The value of this framework depends on real cooperation with partner platforms, real metadata, and practical pilot cases. Platforms. Next slide, please. For major platforms such as SciELO, cooperation can begin from existing strengths. SciELO already have rich experience in open access publishing, article and journal metadata, regional knowledge visibility, and multilingual scholarly communication. OS10 can add a cross-domain mapping layer, a resource relationship model, governance-aware metadata, AI reads, processing, contribution, and reuse recognition and support for cross-border interoperability. The practical path can be low burden. Partners can keep their existing standards and systems. They can provide public metadata samples, develop mapping or crosswalk cases, test selected exchange field, and explore links among literature, data software projects, and services. Okay, next slide, please. Possible partners can begin with mapping SciELO journal and article metadata to the OS10 general and literature metadata framework. From there, we could test public metadata exchange, explore links among publications, datasets, software projects and services, and co-develop indicators for open access, reuse, and knowledge dissemination. The shared value would be stronger international visibility, improved interoperabilities, AI-ready discoverability, better recognition of open knowledge contributions, and participations in international rule co-development. SciELO's experience is especially valuable because it represents not only a publishing platform, but also a long-standing model for regional open access and global source knowledge visibility. Next slide, please. The cooperation pathways can be gradual. It can start with a dialogue to understand partner needs and priority use cases. Then we can move to metadata mapping, comparing fields, vocabularies, and resource relationships. After that, selected public metadata can be used for pilot exchange. The pilot can be small at the beginning, a limited set of fields, or one consequent use case. If the pilot works well, we can move towards joint use cases, monitoring, and improvements, and eventually shared services. Next slide, please. Shared rules become meaningful because when they connect with real platforms and real services. The action recommendations provide the cooperation agenda. The specification framework provides common rules. Partner platforms bring real practices, real data, and real community experience. Through joint partners, we can test whether these ideas work in practice. Through shared services, we can make them useful for researchers, platforms, policy communities, and the wider open science ecosystem. On the next slide, please. We only invite international partners to join this discussion. At this stage, the action recommendations and the specification framework are still open for consultation. More details of the specifications are available at our website following this URL. We hope to continue to discussion with SciELO and other partners, especially around metadata mapping, parent exchange, open access monitoring, and shared use cases. For OS10, this work should be developed through consultation, cooperation, and continuous improvement. And thank you very much. I look forward to your questions and suggestions. Thank you. That's all.
Thank you very much, Professor. Very welcome your presentation. It really provided create a framework to implement and operate open science contents, open science process. So we have now, thank you again. I have now another online presentation with Professor Yu Bei. He is from iFlyTech Research. She is from iFlyTech, that is she introduced us before. She will talk about the LLM development and the AI agent, focusing on scientific literature and knowledge services. So we are really very interested in that. Please, Dr. May, have a good day.
Hello, can you hear me?
Yes.
Sorry, my camera has some issues, so I can't open it right now. I can just share my screen now. Can you see my screen?
Yes.
Yes.
Yes, no problem.
All right. Okay, let me start. Hello, everyone. My name is Yue Bai. I'm a researcher of Beijing iFlyTech Research Institute. Today, my topic is development and applications of LLMs and AI agent in China, focusing on scientific literature and knowledge services. There will be 3 parts of my presentation. Let's move on to the first part, advancement in large language model technology. Artificial intelligence has evolved through 4 distinct waves. The first wave focuses on the theorem proving using early models like logic series and perceptron. The second wave advanced knowledge engineering through in Hopfield network and back propagation. The third wave revolutionized the field with deep learning breakthroughs, including DNNs, CNNs, GANs, AlphaGo, and transformers. And the current fourth wave ushered in the era of large language models, driven by ChatGPT, BERT, pre-training programs, fundamentally natural language processing, and overall AI capability. The development of AI agent is bringing the last mile of productivity by shifting from conversational interactions to complex text execution. Products like OpenCloud enabled AI to perform actual local and cloud text through components like gateway, agent, skills, and memory, rapidly growing into a leading open source ecosystem. Additionally, tools like Cloud Co-work empower general users to direct AI to operate computers and execute multi-step office workflows using natural language, signaling a transformative era of enterprise-wide efficiency gains. Recent advancements have significantly evaluated AI benchmark in code generation, automated agents, and complex reasoning. OpenAI introduced GPT 5.3 Codex and GPT 5.5 in integrate coding efficiency with general-purpose reasoning for workflow automation. Anthropic released Code Sonnet 4.6 and Opus 4.7, achieving breakthroughs in computer use, long context reasoning, and agent planning. Google's Gemini 3.1 Pro enhanced complex reasoning and text decomposition, topping key industry benchmark. Meanwhile, DeepSeek V4 was open-sourced, offering ultra-low inference cost and high-performance long-context capability, collectively driving the next generation of AI productivity. AI is rapidly transitioning from technical breakthroughs to industrial application. We are witnessing a continuous evolution in capability, moving from basic chatbots to advanced agents and organizers. This technical progress driving massive adoption. Notably, Chinese large language model token usage has surged a thousandfold in just 2 years, reaching 140 trillions. This data clearly demonstrates that AI deployment is accelerating. An AI agent is an autonomous system that understands goals, formulates plans, and executes complex tasks, much like a human. It operates through a continuous feedback loop, observing the environment, taking action, and learning from reward to optimize its decision. This intelligence is powered by 4 core components. Memory is to return context, planning to decompose objectives, to functionality to access external resources, and action capability to execute the final workflow. And also, as we know, the open cloud driven by natural language instruction, it performs field operations, workflows, automates browser text, and interacts across multiple IM platforms. It's enabling a transaction from conversational transaction to automated execution. From technical perspective, foundation models are evolving through 3 key trends. First, scaling loads remain effective, ensuring continuous performance gains as model size and data volume increase. Second, the chain of thought reasoning is pushing performance scaling by transforming general models into powerful specialized tools. Finally, the integration of multimodal capability and world models is further accelerating the development of artificial general intelligence. Our laboratory serves as an open innovation platform for AI security technologies. Our mission is to address critical security challenges and across China by integrating resources from leading institutions worldwide. We will conduct strategy and cutting-edge research, build a market-driving R&D organization, and ultimately develop into an internationally recognized center for AI security innovation and talent development. On October 24, 2023, we launched Phase 1 in partner with Huawei as the first domestic 10,000 GPU intelligent computing cluster, capable for training trillion parameter LLMs. It established a competitive advance in super large model training. On this platform, we achieved 90% of the training performance on Ascent 910B, addressed over 500 challenges, and optimized more than 150 operators, with performance continuing to improve. On October 2024, we launched Phase 2 with our partners. We put a lot of computing power into this project, scaling up from 10,000 GPUs to 10,000 P. This huge computing support allows us to train better models and reach top industry standards. It is a big leap for our computing infrastructure. Okay, let's move down to second part, scientific literature, large models, and key technologies. Complex scientific research tasks require advanced AI solutions. iFlyTech Spark meets these high demands with core capabilities like logical reasoning, mathematical competence, and multimodal processing. These features make our large models powerful catalysts, significantly accelerate scientific research and driving a new era of technical innovation. The Spark Research Assistant provides both general and domain-specific scientific services. It's built on the iFlyTech Spark large model. On top of that, we created a special scientific literature large model to boost research, literature analysis, and writing skills. When it comes to general research, we offer tools for achievement investigation, paper review, and academic writing, along with the StarClaw agent to help researchers. For specific vertical domains, we provide tools to find domain knowledge, create automated monitoring reports, and analyze research trends. Together, these intelligence services greatly improve the quality and efficiency of scientific research. Our partnership with the National Science Library, Chinese Academy of Sciences, have driven the continuous evolution of the scientific literature large model. In October 2023, we jointly launched version 1.0, achieving a tenfold increase in research efficiency and laying a solid foundation. In October 2024, we upgrade to version 2.0 together, improving scientific research competence by 10.9% and expanding application boundaries. Looking ahead to October 2024, we released version 3.0, introducing deep thinking and task planning capability to establish an AI-driven programs for deep scientific research. Through this strategy collaboration, we to push the boundary of AI innovation in scientific literature. The 3.0 version significantly improves our data construction process, which include two main parts: unsupervised data processing and SFT data construction. First, we process a massive amount of probably scientific literature, rephrase various field formats, and strictly clean the data. By filtering our low quality and scientific content, we build a solid foundation of high-quality domain data. Secondly, for the SFT data construction, we use advanced techniques to create better training data. We apply a data backward writing method based on expert knowledge. We also use a multiple model collaboration sampling technique. This ensures our model is trained with the highest quality data for deep scientific research. The scientific literature large model 3.0 uses a strict three-step training process to boost the research capability. It starts with the secondary pre-tree. We use tens of millions of unsupervised samples across key scientific fields to build a strong domain foundation. Built on this, supervised fine-tuning uses millions of autonomous examples. By fine-tuning our parameter, the model learns to handle complex tasks like literature research, information extraction, and academic Q&A. To guarantee top quality, refinement learning aligns the model with expert standards, using tens of thousands of human autonomous datasets. Combined with advanced techniques like fast and slow thinking, this creates a highly reliable research assistant. Version 3.0 of our scientific literature large model delivers comprehensive upgrades across 5 core research capabilities. As shown in this chart, it consistently outperformed the version 2.0 in every category, from paper review and translation to knowledge extraction. Let's move on to the third part, exploration of intelligent applications for scientific literature knowledge services. The Spark Research Assistant delivers a complete set of general research services. To start with achievement investigation, the platform automatically tracks domain trends and summarizes key literature. For paper review, researchers can conduct deep analysis on a single article or perform systematic of academic writing. The system provides intelligent proofreading and specialized translation to guarantee high-quality output. Beyond these core tools, our scientific research intelligence agent, like we just did StarClaw, actively assist in accumulating domain skills and recommending new research directions. Users can acquire all these capabilities directly through our online platform. Here is the website. The domestic tracking feature helps researchers stay ahead in their field. Powered by our large model, the system processed vast scientific literature from conference, journals, and preprints. It applies semantic understanding, intelligent retrieval, and comprehensive ranking to identify the most relevant papers. Researchers can explore through recommended topics, keywords, or simply just describe their interest in natural language. The system then delivers precise paper recommendations and clear summaries, inspiring new ideas and keep you informed of the latest breakthrough in your research area. This module is designed to streamline research decision making. Through scholar article retrieval, the system efficiently research for paper and precisely pinpoint relevant research achievements. Once the papers are retrieved, the retrieval results summary automatically exact core domain findings, helping researchers gain a deep understanding of the topic. Furthermore, the intelligence question answering feature allows users to ask specific questions about the literature and receive instant and correct answers. DeepSurf directly address common research challenges like language barriers and time-consuming document organization. It provides cross-lingual technical comprehensions to help researchers overcome language obstacles. The system automatically generates hierarchic outline summaries, allowing users to quickly grasp the context of their field and ensure standardized document organization that meets academic standards. By generating highly trustworthy reviews based on relevant literature and supporting multimodal data, this feature significantly enhances academic precision and logical coherence. Automatically, it improves literature research efficiency by more than 10 times. The single academic paper review feature enables researchers to conduct a deep dive into uploaded article. Once uploading a paper, the system immediately provides an automatic summarization. Researchers can then interact with the content through full text questioning or ask specific questions about particular segments. The system also supports multimodal question answering, allowing users to query information directly from charts and images. Additionally, it recommends related scholar articles to broaden the research scope. This comprehensive analysis ensures a deep understanding of the paper's logical, technical details and academic significance. The multiple papers review feature helps researchers read and analyze many related papers on the same topic together. To handle complex documents, the system breaks them to easily read text, images, and tables and different sections. It then researches across all their all these papers in both Chinese and English to quickly find the key information you need. By combining all the findings, it gives you clear, detailed answer and tells you exactly where the information came from. The academic paper review feature acts like a smart peer reviewer to help you improve your manuscripts. Once you upload your draft, the system deeply analyzes the content using our large language model. It then provides a complete evaluation covering the article overview, strengths, weakness, and grammar section. The examples show how it gives clear feedback and even an overall score. This makes checking your own paper much easier and makes your write better. The academic translation and publishing feature is designed to perfect academic writing. It offers flexible options, allowing you to translate short text directly or upload entire documents for full file translations. Beyond just translation, the English language refinement tools polish your writing to make it sound more professional. The before and after comparison clearly show how the system improves expression accuracy and scholar, ensuring paper meet high accommodation standards. The academic paper proofreading feature of Spark Research Assistants is designed to perfect English academic manuscripts. It automatically detects writing errors, ensuring the accuracy and adherence to scholar standards of your research outputs. Technically, it uses a multimodal interactive automation approach combining with the bin research ranking algorithm to integrate correction outputs from multiple models. The before and after examples clearly show how the system catches the spelling and grammar mistakes, providing precise suggestions to make your writing more professional and natural. Let's move on to the StarClaw. It's a designed to support your entire scientific research workflow. It provides a stable experimental reproduction sandbox and a built-in professional scientific research skill base, carrying everything from topic conception to a final report generation. It uses progressive knowledge reading enhancement technology to achieve deep integration with your personal knowledge base. With its self-evolving mechanisms, it continuously improves its capability while ensuring safe and stable experiment operations. StarClaw is designed to automate the core scientific research workflows through a closed-loop system of reading, thinking, doing, and writing. This system integrates literature phrasing, research capsulation, code experimentation, and academic writing, enabling AI to deeply understand and execute the full research life cycle. The first is the read stage, allows the agent to perform in-depth literature decomposition with automated precision. Progressively retrieve an agent's scheduled retrieval capability. The idea stage helps you come up with research ideas by focusing on defining your problem, thinking across different fields, and improve your new ideas. The implementation state lets you run code safely in a sandbox, conform your plan, reproduce experiments step by step, and keep your progress saved. The writing stage helps you turn your research into formal documentation by organizing context, polishing your text, and supporting multimodal typesetting. Here is an example. You can see SciELO help spark new scientific ideas and drive breakthroughs in your research. It starts by analyzing your ideas and combining ideas from different fields to help you think outside the box, and finally refine those ideas into clear, actionable research direction. As shown in the example, it first identifies frontier topics in your target field, then explore cross-disciplinary paths, and finally shape them into a concrete, implementable research concept. Here is another example. SciELO makes easy to reproduce scientific experiments from start to finish. When you ask it to replicate a paper's work, it automatically sets up the whole environment, installing the needed tools, checking your CPU and memory, and downloading the right dataset. It writes the code based on the paper's method, including all the train setting, data loading steps, and model details. It runs the experiment live and keeps you updated with real-time progress, like training loss and accuracy numbers. Once everything is done, it packages all the code, results, and chart into a clear summary report you can download and use right now. Thank you for your listening. That's all about my today's presentation. Here is the website of our research assistant. Please feel free to try about that. We'd like to hear about your suggestions.
Thank you very much, Dr. Mai, for this very good overview of the evolution of the AI, the incredible infrastructure you have been developing in high-tech, and also the new advances that is coming in terms of the technology of the agents, etc. So we come back to SciELO to share the SciELO technological infrastructure and the publishing schema by Roberta Takenaka, who is coordinator of the system development and the technology of the SciELO, and Rafael Pesuno, who is consultant for SciELO program in the area of the system development. Roberta, please.
Good afternoon, everyone. My name is Roberta Takenaka, and I coordinate the system development technology at SciELO program in Brazil. And sorry. In this session, I will walk you through the SciELO technology infrastructure. What we have today and what are you building and where you see opportunities for collaboration. Next. Before you get into the details, here a quick overview of the agenda. It's an editorial production platform for scientific publishing. It takes a Word document and converts it into a validated XML called the SciELO Publishing Schema. Along the way, it uses AI to help with markup, applies style rules, and supports manual review when needed. Everything is connected through a REST API, so can integrate with systems that journals and collections already use. Next. Let me give you some context about SciELO Network. There is not a single platform. It's a cooperative network of independent collection. Country or institution runs its own collection. There are on SciELO collection in 18 countries. The key principle is each collection has full editorial autonomy, but all collections share the same methodology, quality standards, and a commitment to open access. Next. So what exactly is heard across all collections? First, the SCS standard, a common XML schema that makes content interoperable across all collections. A shared methodology and the quality criteria applied consistently in every country. And third, open access requirements. All SciELO content is freely accessible with no paywall. The shared foundation is what makes SciELO work as a network rather than just a collection of separate websites. Next. At the same time, each collection is independent in several important ways. Each collection has own editorial governance managed by local institutions with their own policies. Each one decides which journals meet its regional criteria for inclusion. Content is published in local languages, reflecting regional scientific priorities. And each collection negotiates its own demand. So the network is both unified and centralized. That balance is intentional. Next, please. Now let's look at the current situation, what platform looks like today. The workflow has several steps: admission, XML markup, validation, and dissemination to external database like PubMed, Prospective, and others. But right now, each step is handled by separate tool, and there is no standard connection between them. That is what we mentioned yesterday about the old platform, actually the current platform. It's created a real problem. At least the editorial history gets lost, and I introduced every part. There's no visibility or a lot of manual effort is required to each step. Next, please. So the new platform solves this by making all components shared in a single XML file. Every step in editorial process adds to that file's permanent history. So the idea is integrate more the applications. At the center is the XML, according to the Publishing Schema, the single source of the truth. Salesforce handles the XML production markup. That load system receives, validates, packages, and publishes the article. The collection website publishes the content, analytics generates this indicator, and all this connects to external database and for print and data repository formats. Next. So the status of the development. Some parts are completed, XML packaging, validation, and generation are completed. Other are in progress, complete, or to improve. Some integrations have not started yet. The third event history in XML and the connection to core upload and analytic applications. These are the main gaps we are still working to close. Next, please. This slide shows how SciELO tools could fit into full editorial pipeline. It is at the center, connect everything, repeat server, data repositories, review systems like UGS or LLMs, and the load system, the collection websites, for PD assignment and export, transportation, and analytics to the network. Every connection uses REST API. The XML file through the entire life cycle from print request to review, duplication, and exportation. And every event is recorded in that file. Next, please. One important design choice is that all external integration points at optional and platform agnostic. A preprint server, whether it is preprint server org or an external platform, would send events via post to record the depositing to preview the version. Preview system like OGS or others can send review rounds and decision via webhook. A data repository can send the data set or to get recorded in articles, XML history. Now, there is no chance to be required to the system, just send events using APIs. And we the main use case today is reference tagging using AI. Giving a list of reference, the AI identifies authors, title, year, DOI, and reference type. Can run through an external API, a local GPU, or local CPU is configured. On the working rule, unpublished articles must never be sent to an external AI service. Published content is confidential. Our recommendation is to use a local on-premise language model so that no data leaves things. External ER is only accepted for content that is already published. Next. Some tools currently focus on the final published article, but the goal is cover a full life cycle of research communication objects. That includes preprints, version for review with the full life cycle recorded. That's XML history. Research data where it was event, the data size DOI, and the manuscript document is still under editorial review. The last three are integration gaps. They are the next phase of the development. Next, please. In slide, summarize what you see needs to be built. The four main gaps are integration with the protein server to track the full life cycle from the post application, integration with the data repository to report the data set post event, the XML, to review connectors to report every editorial event, edition, review rounds, decision, production, publication, with timestamps. And specialized AI for self-publishing schema that makes tagging, validation, and metadata extraction. All these are not designed to be a platform agnostic and the API based. Use welcome collaboration for in next. Beyond the integration gaps, there are several places where AI can be improved and that already exist. In doc text to XML conversion, AI can detect heading levels, table tags, and figure captions, reduce manual fix. In PDF generation, an AI layout engineer can handle complex multi-columns articles like tables and equations. For exports to cross-heavy, DOAJ and SciELO citation index, AI can automatic self-publishing schema fields and flag missing the metadata. And for validation, AI can suggest correction in XML, PDF, or any generated report. These are practical near-term improvements, not long-term. Please. So that's it. There are links to our repository, the documentation of the self-publishing schema, and also for our textbooks library, which manage all kind of functionality of the XML files.
Very good, Laura. Now, before we discuss what Roberta just presented, we have now to Pesutto, Damasceno, principal.
Should I unmute my mic?
No.
Okay. So, good afternoon, everyone. Let me share my screen here. The idea of my presentation is to show an early stage version of SciELO tools, which Roberta speaks a lot. Absolutely about. So this is the main screen of SciELO tools. I have to remember this is a very early stage version. This version in particular is only on my machine because this presentation, but we have a version on homologation server which is not public yet. Let me show you some slides previously. Fine. So, as Roberto mentioned, the system is composed of many stages, but mainly we have 5 stages: inputs, format conversion, information discovery, internal structure generation, and validation. Each of the stages has its own procedures and characteristics. So let's go to the interface, which will be much simpler to explain. The idea of the system is to enter a document in docx or XML or SPS package, for example, and then the system will generate all the assets, XML validation, package validation, HTML, and PDF versions. Most of the part is runs on LLM. Another part runs on rules-based approach. Why this? Because we understand that GPU access cannot be a reality for everyone. So we try to develop systems that runs on CPU or even without LLM. Okay. This version in particular supports several AI models, but as Roberto mentioned it, the idea is to run LLMs locally. So here I am enabled to set up a LLM model using a framework called Polyama, for example. And here I have a server, but not an organizational server. It's my private server, where there I have a list of models that can help me to obtain worse or better results depending on the model capacity. And here, these results here I run using a time model, GMA4. It's a model that fits on a GPU with 4 gigabytes. It's not expensive GPU. The difference is that the response time could be faster or slower depending on the GPU. But when I input a document, for example, like this, it's a Word document, and as we know, a document like this can have different style configurations. The title has a font size 12 or even 14, it's in italic, etc. And this fits to every content we have here. So it's hard to open a docx file and simply generate the XML file, for example. We had to deal with Sorry. We have to deal with a list of methods to convert the input into a better into a content format that fits better to the LLM, for example. One of the things that we use to do that is a library called doclink. Through doclink, we can input a .x file converted to a pure text file. For example, that document, that Word document that I showed, it's converted to this kind of document. So we have semi-structured content, which is much better through the LLM or VLM, for example, if we want to use images. And then another way, you can just use XML libraries to extract the Word document. As you may know, Word document is actually a zip document. When we extract that document, we access the internal structure of the Word document. And this internal structure could be very bad. And let me show you an example. Things like this. We have a paragraph starting on one line here, sorry, 2001, for example, and ending several lines before that, after that. And this kind of thing is bad for LLMs in general, because we have, how can I say in a polite way, much trash behind around the text that matters. So we have to clean this data and feed the LLM with better content. So this is the stage that we call true format conversion. We have a third step, which is information discovery. By information discovery, I'm not speaking here regarding the analysis in the analysis sense. I'm speaking in the metadata detection sense. So using this kind of content here, we can ask LLM to give us something like, who are the authors of this paper? What is the archive of the authors? What is the title? What's the translated titles, and so on. And then we have a resulting response like this. We can here in the HTML preview, we can have a list of authors with the archive years, the title, the abstract, everything extracted and automatic way. This version in particular is a hybrid version where things are extracted using LLMs and other things are extracted using rule-based approach. I mean, for the citations, for example, they have a clear structure that fits very well to regular expressions. So we can construct a bunch of regular expressions and pass the whole article, and extract all the reference present. And the systems work this way right now. So these repetitive tasks, which a professional would take too long to do, the system can cut this time, short this time, and result and give a result that is much faster. Okay. Let me check. I'm missing something. Okay. Let me go back to the system itself. So I show you a lot of files here, but let's the system. Right. Okay. Okay, let's go back to the system. This top bar here is basically crazy.
Hello. It's the bottom of this.
I can see the header of the development here. Okay.
Easy. I recommend it.
Okay. Okay. Computers 30 years ago. It's just that. Okay. So remember we have our entries menu here. And then we have the articles menu. If we inspect this article menu, we can check the preview HTML button, which you can see here, the downloads button, where we can download a PDF version of this document. Okay. Should go. This PDF file here was generated through the system using a well-formatted XML file. It's not perfect yet, but we have a good version. The citations marked. We have all the metadata that matters. Of course, this is a default layout. We can do some work there to support one layout, one column layout, 3 columns layout, everything else then matters. We have to do some work on tables, in equations, but it's a version that works. Another way to input a document is just as I showed, XML file. If we have a well-marked XML file, we are able to produce a good PDF. Let me show you a PDF and a HTML resulting from a .x file, which is the second here. If we see here, the preview, we have a good result, but this result here depends on the LLM. Experimenting with GMA4 LLM, for example, we have a good result. We have the abstract correctly. The title here is in English, but the system detects the Spanish version. I think it's a bug of our preview here, which is showing the English version instead of the Spanish version. And see how the citations are marked. We have also the dates, history of the paper, which usually takes it's in the front matter. Another thing that I have to mention is relating to the structure generated. Here, related to this .x, we have the XML structure that we can edit, save, and generate another versions of HTML and PDF files. So here we have the front, which all the text detected. So the DOI is marked as an article ID. A paragraph with language, it's the main title of the article in Spanish, the translated version in English, the authors, everything detected automatically from the .x file. This is related to the front. The back, it uses rules or LLM. It depends on the complex of the disease. But right now we are using rules, regular expressions, etc. The body yet are using rules. We believe that LLM has the potential to improve this detection because some article can have an abstract title or section title that has a bold style, a 14 font size, but it depends on the journal, the author, and I think that's not a good idea to create rules for those kind of things. It will give you a result, but can give you wrong results. And LLM has a potential to produce better results, including to the body section. Another thing that our system has working, the validation stage. Those .x generated an XML file, and we have access to a validation section related to the XML generated. So here we have an example of results showing that related to the XML generated, we have missing fields, missing tags, and so on. And we have a classification here regarding the complexity of the problem. And then we can see this list, open the XML structure, fix things, and generate a new version. The last thing I would like to mention is the references section. Each .x file that we include here or XML file, the system is capable of reading the references list and produce the duplicated unified list of references here. So we have one reference here, for example, and this is converted to a JSON structure and a marked XML structure. And a person can give a score to that citation, representing the quality of the comparison. The idea is to use this as a sort of training that data to a future product person. So I think I didn't miss anything. So I think thank you about.
Thank you. Okay, now we will say change topic and we go to other very complex one, but not related yet to infrastructure, but we will need to discuss how infrastructure can help us on the issue of the ethics in research communications. Okay, so when we celebrated 25 years of SciELO, which was in 2023, we agreed to create ethics office, which we call now today SciELO Ethics. And it became a very, very important issue now. Okay. So are you ready?
Yes.
Okay. Professor Sigmar, you have the profile, but he is long friend of SciELO. he was president of the Brazilian Association of Scientific Editors, which Edna introduced us yesterday. And he is now the leadership with the ethics, obviously the ethics processing within the SciELO Network. Sigma.
Okay, good afternoon. It's a pleasure to be here with you today and talk a bit about our SciELO Ethics. Sorry, SciELO. Well, one of our main goals is the quality in research communication in open science. Then, to ensure this, to support this, was created the Office of Ethics and Good Practices in Research Communication, the SciELO Ethics. Like Abel said, during the SciELO 25 years meeting, we was established the aim of providing institutional support guidance to index journals through SciELO Ethics. Then SciELO Ethics was created a support instance for the advisory committees of the SciELO program in order to relate it to ethics. The main goal is promoting integrity and best practices in research communications across the SciELO network, who demands maximum transparency in full alignment with the open science. To communication objects includes manuscript submitted and published by SciELO preprint server and to the journals of SciELO network. Research data submitted to SciELO data, and books published in SciELO books collection. Very important is that SciELO Ethics will act only upon receiving a formal complaint, whether from a reader, author, reviewer, editor, institutional publisher, or the SciELO program coordinators. It does not act on its own initiative, only when formal action is requested. The coordinator of the program is appointed by SciELO program advisor committees with a 5-year term, with reappointment permitted, and he has operational independence to act to the best practice in scientific communication. And the coordinator has a seat on the SciELO program advisor committees, always in Brazil, and when some collection have a problem, we can participate in this program too. The evaluation committee, when a case happens, is formed by a coordinator, a representative from the SciELO program management, 3 SciELO editors. This is very important. We ask to each case, we ask 3 different SciELO editors from the relevant fields. One of them has to be from the advisor committee of that field. One representative of the indexation unit from SciELO Brazil who help us to make all the process. If required, it could be external ad hoc advisors too. other thing very important is all the decisions the work group made must be supported by an appropriate legal opinion to prevent litigation, and to have some problems to SciELO Network. After the approval, the legal approval, the coordinator present a circumstantial report for analysis by the advisory committee, and the advisory committee has the ultimate decision-making power. Then the SciELO Ethics make all the process, but the final decision is from the advisory committee. Our work is based in this scope affirmation. Journals must ensure the integrity of the manuscripts and research they publish, irrespective of when potential ethical issues may arise. Until last week, because we have 3 new cases in this week, we had 23 cases from Brazil, now 3 more, 1 from Chile, 2 from Peru, 1 from Ecuador. Julio helped us in these cases of the Latin American network when it happens. Through the year, we have 4 cases before the establishment of the SciELO Ethics, but these 4 cases were very important to establish the SciELO Ethics. They gave support to form SciELO Ethics. In 2023, the meeting was in September. After September, we had 3 cases. In 2025, 12 cases, and in 2026, 80 plus 3, we had 11 cases. The cases are increasing a lot during the year, how the network is known about the SciELO Ethics. In these cases, 4 of them are from preprints. The cases, 2 of them from authorship, 1 for APC charges, 1 for ethics committee, 1 data fabrication, 1 retraction, 1 in image use, 2 copyright, 2 editorial misconduct, 6 the predatory journals, and 10 plagiarism, self-plagiarism, or suspect plagiarism. The result, we have 3 journals delisted from the collection due to predatory practice, 24 follow-up actions with the complainants, editors, and the responsible authorities of each journal. We made a suggestion, and the editor could have the responsibility, the action he will make. This is our page, and where there is a formula. A formula you can make your
The complaint.
The complaint, yes, the complaint. You can make the complaint, and could be anonymous or not. It's the people who made the complaint can choose if he wants animal or not. And in the last month, we present by the first time our SciELO Ethics at the World Conference Research Integrity in Canada. We made a poster to present the SciELO Ethics to the academy. Well, the big problem we have, I think you can show in this picture. Here you can see the most dangerous animal in the world, responsible for millions of deaths per year. By its side, a great white shark swims, completely unaware of the danger. So the great problem is the human being. This a fast presentation about our SciELO.
Thank you, Sigmar. Opening for comments. This is becoming a big issue with fake news, with artificial intelligence, so on. And improving the way SciELO Ethics work, because we are learning.
Yeah, every day.
We have easy cases and very, very cases. And we are now, after a lawyer review, we are restructuring the entire site and the process to anticipate judicialization of the process. Any comments? No? Okay, so let's go to the next presentation, which is from Dr. Deborah Santos, Deborah Oliveira Santos. She is the executive director of recently established network review regarding reproducibility, Brazilian Reproducibility Network. So she will share with us a presentation regarding promoting reproducibility in research ecosystems and the recommendations from the Brazilian Reproducibility Network. Please, Deborah.
Thank you, Professor Abel. Let me just have 1 second to adjust here the presentation. First of all, I want to thank the SciELO for the invitation for Brazilian Reproducibility Network to giving this short talk with you guys today. On today's talk, I'll be addressing a brief overview on how BRRNs was created and how has been developing throughout these years, the actions we have been carrying out for promoting open and reproducible science in Brazil, the recommendations we have made for evaluation systems and research communication, and a brief wrap-up with few takeaways based on our Brazilian experience. So, our journey starts in 2019. In that year, UKRN was launched in Brazil and was launched in the UK. And in Brazil, Professor Olavo Amaral was leading the Brazilian Reproducibility Initiative, which was the largest replication project in the world, involving 56 labs and 200 researchers dedicated to replicate experiments from Brazilian biomedical literature, and recently received the Einstein Foundation Award recognizing its relevance. As reproducibility networks started to spread across the globe, in Brazil, this group of researchers decided to join forces to transform the replication project into the Brazilian Reproducibility Network. BRRN was then created in 2023, and since then, in the international scenario, we have the creation of the Global Federations of Reproducibility Networks, and BRRN experienced consistent growth with stable funding, members from different locations in Brazil, many ongoing projects, and engagement with national and international stakeholders. The fact is that Brazil provides a very particular case for these types of initiative. We are the 5th largest country in the world, corresponding to 83% the size of Europe. We have one language being spoken throughout the country, which is Portuguese. But at the same time, we also have share in our country a very deep and structural, cultural, and economic differences between those regions, which are somewhat balanced, but still reflected in our research system, which is largely dependent on public infrastructure, with public universities and public funding agencies being the main drivers behind most of our scientific production. With that in mind, the BRN aims to make Brazilian science more trustworthy through the adoption of open, responsible, rigorous, collaborative, and reproducible research practices. And our mission is to bring together researchers and stakeholders to foster the debate on transparency and reproducibility in research. Since our launch, we are present in 70% of Brazilian territory, which is a big deal. We have members from different research fields and career stages, and our network has now more than 100 members, including ambassadors, individual members, research groups, scientific societies, institutions, and also scientific journals. We understand that reproducibility is something that can't be achieved in analysis methods, results, and inferences. And based on that understanding, we organize our actions into 4 main focus areas. So community building and consolidation focused on connecting our members and promoting collaborations between them. Advocacy focused on keeping open dialogue and promoting systemic change. Meta-science focused on obtaining evidence about Brazilian science and informing other actions toward concrete change. And training and educational resources, which is focused on disseminating existing educational resources and developing new materials. I will talk about this in detail to give you a better look into our actions. So, first, on community building and consolidation, promoting change in how science is conducted in large countries like Brazil requires efforts to ensure that initiatives reach every corner of the country. So community is a way to disseminate open and reproducible science. We do active search for new members aligned with our aims and hold regular meetings with all members on topics of common interest. And we also have an ambassadors program focused on training new leaders to develop one-year projects in their local communities. Besides that, changes also requires support from institutions. So we do active networking with national and international stakeholders in different events, actions, and boards. And we are also contributing to the current National Action Plan on Open Government Partnership, particularly in the commitment of promoting transparent, responsible, collaborative, and reproducible scientific practices. However, as we know, the adoption of open science and reproducible practices requires some level of instruction and knowledge updating. So with that in mind, we are also developing an online course on transparent, collaborative, and reproducible research practices. We translate and adapt existing materials to the Brazilian context, and we hold webinars and publish blog posts on specific topics related to reproducibility in different research areas. But regarding meta-science, we have this focus that knowing how science is done in Brazil could help us to be more efficient and effective in our own actions. So we carry out meta-science projects to better comprehend the Brazilian scientific context. Here I want to highlight 2 actions on this focus area in particular. We created a funding line to support our members in developing and executing meta-scientific projects in their research fields. And we are also carrying out a project now on developing and testing interventions to improve open and reproducible practices in Brazilian graduate programs. Among all of these actions, I want to highlight particularly the development of designed recommendations for stakeholders. Our experience has shown that raising awareness among actors in a position to promote change can benefit from practical recommendations, which lists the areas of improvement that these stakeholders can go through, alongside with resources, tools, and examples that can facilitate the implementation process and the development of infrastructure. Here is an example of this. In 2024, we developed recommendations for enhancing open and reproducible science for CAPES, the Brazilian agency responsible for the graduate program's assessment. And this led to the inclusion of an evaluation dimension on open science and good research practices in their current assessment, which provoked us for now elaborate new recommendations now for the graduate program's coordinators so they can implement those practices in their programs, aligning those practices with the new assessment guidelines. We also have elaborated recommendations for the Brazilian scientific journals. Those were focused specifically on requiring data and code sharing, requiring systemic description of methods and results, focusing the evaluation on methodological rigor, sharing peer reviews, encouraging publication of replication studies, and also encouraging the pre-registration of protocols. All of these aligned with our understanding that reproducibility can happen in methods, results, inferences, and so on. These recommendations for journals, they were developed with the participation of editors from national journals from different fields of research. They were classified based on the difficulty level, so easy, intermediate, and advanced, to assist the implementation process. And they also can be adapted to different fields of study based on the particularities of each field. So, to wrap up this conversation, I want to leave you with a few takeaways from our Brazilian experience. First, large countries with research systems that rely on public infrastructure requires coordinated efforts to promote open and reproducible science. These coordinated efforts, they must have a dual approach. So this means that initiatives should aim to, at the same time, promoting change in scientific culture, so a bottom-up strategy, and also creating incentives and infrastructure that can facilitate the cultural change, so a top-down strategy. It's important to have both. And finally, initiatives that focus on stakeholders in a position to promote relevant change benefits from practical recommendations, ideally developed in dialogue with them, and that can be adapted to the particularities of each context and that are easily to implement. That's it for my part. I want to thank again SciELO for the invitation for this talk, and to those who are interested in learning more about what we are doing, here's our contact information, and I will put also the website in the chat so you can see better about what we have been doing. Thank you again.
Thank you, Dr. Deborah. Very important presentation, very important issue. If you don't have any new issues, I am seeking to finish by today our workshop because we did not launch it. We started very early, so you have all the right to stop now. Okay, so see you tomorrow, and tomorrow we have in the morning, we will have more discussion on retreats, and that you will be very welcome in your group. And also, we will share with you about what we have in SciELO regarding research evaluation, journal evaluation, so on. Rafael will also introduce what will have been done. As soon as we finish the presentation, we will then work on how to advance the lines of our cooperation. Okay, so thank you very much, and we'll see you tomorrow.